we're going to talk about things in the night sky for December, and there's quite a few things that we can talk about. First off, here's the calendar of the lunar cycle for the month, and I've added a couple of other uh, pulses. We have the moon and Saturn on the 17th, obviously the solstice, the day before we're going to have our party. Moon and Venus on the 9th, and the moon and Jupiter on the 22nd. So those might be good photo ops for people with the terrestrial camera. They're looking forward to seeing that. So, anyone here have heard of the lunar X and the lunar V? I'm sure everybody else is, yes. This is not I took this from a site, so this is like for kids. So they are famous optical features on the moon, visible through telescopes. So when the moon's terminator, or line between light and dark on the moon, is located in just the right place, you can see the letter X or the letter V on the moon's surface. A sign of alien visitation? No. Lunar X is a great example of how lighting and topography can combine on a planet or moon to produce a pattern that seems familiar to the human eye. In reality, the illusion of the lunar X is created by sunlight falling on the rims and ridges between the craters Lacali, Belanki, and Purbach. The V is caused by lighting illuminating the crater Urquhart, along with several smaller craters. These transient lunar features are visible on the surface for about 4 hours once a month. They are most striking when they are visible on the shadow side of the terminator, but they will remain visible against the lunar surface even after the terminator has moved because they are brighter than the surrounding area. Now here's a little visualization that shows the moon's phases hourly. In this case, I've picked the end for this month in December. The moon always keeps the same face to us, but not exactly the same face. Because of the tilt and shape of its orbit, we see the moon from slightly different angles over the course of a month. When the moon is compressed into 24 seconds, as is in this animation, our changing view of the moon makes it look like it's wobbling. This wobble is called libration from Libra, the scale. Supplemental graphs show the moon's orbit, sub-solar and sub-Earth points, and the moon's distance from the Earth at true scale. The little tiny moon over on the right. Craters near the terminator are labeled Apollo landing sites and Marina and albedo features in sunlight. So let's see if this... Planets. What planets are going to be seen this month? Saturn is well placed high in the southern sky as twilight falls. Plan your viewing in the early evening as it sets by about 9 p.m. Local time, the ringed planet is located in the southwest Aquarius, about 20 degrees above the west of the formal hut, the only first magnitude star sitting lower in the southern sky. A beautiful 5-day-old crescent moon stands 3 degrees south of Saturn on the 17th. Saturn glows at a magnitude of 0.8 to 0.9 this month and is receding from Earth after opposition in August. By mid-December, it lies 10 astronomical units, or about 130 million miles away. And 1 astronomical unit, as you know, is the average Earth-Sun distance from the Earth. Through a telescope, its disk is 16 seconds. The major axis of the rings stretches 38 minutes early in December, diminishing to about 36 by the end of the month. The tilt of the rings on our line of sight drops to 9 seconds, allowing clear views of most of the planetary disk. Titan is the brightest of Saturn's moons, spot it shining at magnitude 8.7, standing roughly due north of the planet on the 12th and the 28th, and roughly south on December, well, a couple of days ago, and the 20th. And the smaller planets are also observable through a small telescope, and they shine about the magnitude 10. So following are approximate times, plan to observe for 15 to 20 minutes start of each transit. Tethys begins transiting at about 8:40 p.m. on the 7th, which is tomorrow, crosses for about 90 minutes. On the 24th, the event begins around 8:27 again, and lasts for, this time, 108 minutes. It's difficult to see the moon visually because of the bright disk of the planet. The events are best recorded with high-speed video cameras designed for planetary observation. Aegyptus, if that's pronounced correctly, is just past the brighter western elongation in late November and moves closer to Saturn from our perspective, reaching superior conjunction on December 18th. That's already passed. Follow it towards the superior conjunction where it stands about 24 seconds southeast of the planet center. Now the planet visible is Neptune. It's going to be visible all evening. So it sinks low in the west before midnight, so catch it early. It shines at a magnitude of 7.7 to 7.8. Requiring binoculars to view it, Neptune lies on the border of the northeast Aquarius and northwest Pisces, just south of the circlet asterism in Pisces. The planet lies some 29.9 AU or 2.8 billion miles from the Earth. It's a tiny bluish disk. If you've ever seen it, it's actually very pretty when you do catch a glimpse of it. In retrograde motion, ends in a few days, and it barely moves against the background of the stars all month. And of course, we have Jupiter. It's visible nearly all night long and continues its retrograde path through Aries. It fades slightly from magnitude 2.8 at the beginning of this month to about magnitude minus 2.8 to minus 2.6 by the end of the month. The planet is a spectacular object, and it's joined by a gibbous moon on the 21st and 22nd. Through a telescope, Jupiter's disk is readily visible, spanning 48 arc seconds, shrinking to the end of the month to about 44 arc seconds. The Great Red Spot also makes its appearances along the way. You have to find the app that shows you when best time to go out and try to capture the picture of the red spot. And you don't really need a big telescope for that. A small telescope. People have seen taking pictures with their iPhones and sticking them up to the lens and getting amazing shots. It's a pretty bright object. Highlights to watch this month, there's a series of Io transits. Io transits, well, the next one's is actually tonight, the 13th, the 20th, and then the 27th and 28th. I've done that on occasion, just watching it transit. It's a nice thing. You see it actually progress over the course of the night fairly quickly. On the 6th, it occurs early in the evening, so it's probably already past us. Europa transits on the 12th and the 19th. Ganymede transits in the southern polar region. Repeats it December 8th and 9th, beginning about 1:40 in the morning. So that would be December 9th in the east. And it's still the 8th in the Western time zone, ending 92 minutes later. Let's skip down. We also have Uranus. Is visible late into the night. It is only a month past opposition. It stands roughly midway between Jupiter and the Pleiades star cluster, located about 9 degrees southeast of M45. It's a small group of stars shining between 4 and 6 magnitude. The Delta Aritis is brightest and useful signpost for finding Uranus. The bluish-green planet has a magnitude of 5.7 and lies 2 to 3 degrees southwest of that star during December. Uranus travels westward as its retrograde path continues, carrying it farther from Delta. The planet stands at 18.8 AU, or 1.75 billion miles from Earth, and through a moderate telescope, it's about 4 arc seconds wide. So Venus rises shortly before 4 a.m. local time in Virgo in early December. As it approaches the border of Libra, you'll find a lovely 26-day-old crescent moon, some 4 degrees south of Venus on the 9th. 2 days later, Venus crosses into Libra, passing less than 2 degrees north of Zubinel Janubi. Venus now is at a magnitude of minus 4.1. Its first magnitude, Arcturus in Bootes, shining at 35 degrees above the planet in the sky. It continues to cross Libra and ends, where is it? Continues to cross Libra and ends the month just short of Scorpius. It stands 10.5 degrees above Antares, Scorpion's first magnitude red giant, on the 31st. Mars is too close to the sun to observe after its conjunction. I take issue with that because I'm sure there are some people that are going to photograph it. It reaches winter solstice on the 21st at 10:37 p.m. when the sun appears at its farthest south on the celestial sphere and begins its journey northward. So we do have a few comets, and I listed some. I'm going to go into a couple of them. An 8th magnitude comet rivaling the brightness of Messier galaxies is welcome sight under dark skies. Knuckle down as you stay up until 1 a.m. for 62P to rise in the east above the blue-white Regulus, the heart of Leo, discovered in 1965. It returns every 6.2 years to a spot 25% farther from the sun than the Earth. This time it comes closest to the sun on the 25th. Its size is unknown, but it can't be bigger than a mile because 7th magnitude is about as bright as it gets. The dark sky observing window opens yesterday after midnight and before moonrise and closes on the 17th as the first waxing first quarter moon gets in the way. Imagers should shoot on the night of the 28th when the greenish comet grazes the Leo trio. Comet 62P, like I said, will make its close approach on the 25th. It's going to be accessible from about 11 o'clock in the evening, and it'll be about 21 degrees above the horizon. If that's not enough for you, then we have P12. Hans Brooks is going to be sliding past Vega. It's visible in an 8-inch scope, and it's a small 10th magnitude fuzz. So maybe something to look at or photograph. You can keep going. You can get 144P, and that's going to be between Jupiter and Uranus in Aries. It was discovered in 1994. It makes a complete revolution around the sun in 7.6 years. The comet will approach our planet on the 12th, and the 25th next year it will be at its closest point to the Earth. So, okay. And next year, I'm not sure. That was a little confusing. I'm not sure if they meant next year, January, or the year after in 2025. I just what I read.
There's the fact that at the beginning of the century, who was in, I think it was Geneva, New York, or that area, so he was a comment on wondering if this was something he discovered. I guess I could look it up on Wikipedia.
Well,
right?
from what I read, it said it was from 1990, discovered in. Oh no, that was the other one, discovered in '94. So that it may very well be. Where is okay? Let's go on. So we also have a couple of asteroids that might be some people may want to look at. Asteroid 4 Vesta, a low place lying in the constellation Orion, well above the horizon for much of the night. Regardless of your location, 4 Vesta will reach its brightest point in the sky around midnight. Starting to be visible, it says here, from about 6:30 to about 5 in the morning. But it becomes accessible a little bit later when it rises to an altitude of 21 degrees above the eastern horizon. I guess so if you're down by the water, you see it sooner. They'll become inaccessible again by 5 in the morning. Uh, at the same time, for Vesta passes opposition, it also makes its closest approach to the Earth. This happens because Vesta lies opposite to the sun in the night sky. The solar system is lined up so that 4 Vesta and the Earth and the sun will lie in a straight line with the Earth in the middle on the same side of the sun as 4 Vesta. Another asteroid is 9 Metis. It's going to be lying in the constellation of Gemini. Regardless of your location, it'll reach its highest point around midnight again. Again, it's going to be pretty much from dusk to dawn. It should be visible. What I'm going to do is these slides, I'm going to make a PDF and I'll put it out on the list spot so you don't have to remember everything I'm saying. So the video will also be out there too. Okay, so that's basically the two that I came across. There was several others, more minor ones, but now we do have a plethora of meteor showers. The Puppet-Velde meteor shower became active on the 1st and through the 15th, producing a peak rate of about around the 7th, which will be tomorrow. Over the time, shower will radiate point to the constellation Vela, is above the horizon. Let's see. Shower likely to produce its best display around 3 in the morning. It's expected to reach a peak activity at noon, so you're going to have to go earlier in the morning to see it. And they're thinking a peak of 10 meteors per hour, again, in a dark sky situation. So if you see 1 or 2 an hour, you're probably doing pretty well for yourself. Let's see, what else do we have? We have the monoceratid meteor shower that's active from the 5th to the 20th and peaking on the 9th. Again, that will be visible about 7 o'clock in the evening when it rises above 21 degrees. Let's see. At its peak, it's expected to produce a nominal rate of 2 meteors per hour. So I wouldn't lose any sleep over this one. And in practice, the real life will fall short. The only saving grace is that the moonlight will present minimal interference. We have the Hydrid meteor shower, that's from the 3rd to the 15th, producing a peak rate on the 12th. And that, let's see if we can see. Okay. I don't have a number for the number of likely. Oh, again, another 2. Then we have the Geminid meteor shower. That's from the 4th to the 17th. That's the one you want to see. Peaking at around the 14th. And it's expected from here will remain active till dawn. Best display is about 2 in the morning. And it's rated to be a nominal 120 meteors per hour, which is going to be good. And the peak will be close to a new moon. So we might actually get to see some meteors this year. I know in past years, the moon has been too bright to see anything but the brightest meteors. And I don't know if the parks are going to be open. Yeah. So that may be a good one to we could all come out and see. And there are a couple of others which I'm not going to. You can read about them. I have them on there, and you can look them up. So that's most of the basic talk. So I just want to digress, and I want to just some more interesting facts about Mercury. Now, as you know, Mercury's the speedster in the group. So what have human beings decided to do? Well, they created the Flash, right? That's DC Comics. Then we have Whizzer. That's Marvel. That was their first. I don't know if Whizzer was the right name for a speedster, but then we had Blur and we had Quicksilver. But I digress. This is not the Mercury I'm talking about. That's another lecture that I may come up with. This is the Mercury I want to talk about. So some facts about Mercury. I know we've had some discussions recently about Mercury's comet tail, and it's all very good. So I'm going back to basics. I'm just going to give a brief overview of Mercury. Uh, Mercury's day is just 88 days long. A solar day, which is different, is 176 Earth days, while a sidereal day is 59. So the solar day is the time noon on the planet's surface of Mercury that lasts while the sidereal day is the rotation of on a fixed point. Mercury's tidally locked to the sun over time, or almost tidally locked, it's getting there, slowed the rotation of the planet to almost uh, match its orbit around the sun. It's the smallest of our 8 planets, one of the 5 planets visible to the naked eye through antiquity. It's the second densest planet, even though the planet is small. Mercury is very dense. Each cubic centimeter has a density of 4.5 grams, with only the Earth having a higher density. And Mercury has wrinkles. This iron core of the planet cooled and contracted. The surface of the planet became wrinkled. Scientists have called those wrinkles labate scarps. The scarps can be up to a mile high and hundreds of miles long. NASA recently have come to believe that the solid iron core could in fact be molten. Normally, the core of smaller planets cools rapidly, but after extensive research, the results were in that not expecting. Scientists now believe that the core contains a lighter element such as sulfur, which could have a lower melting temperature. It's estimated the core makes up 42% of its volume, while Earth's core makes up only 17%. And Mercury is only the second hottest planet. That honor goes to Venus. Venus experiences temperatures about 427 degrees Celsius. Mercury, so I'm reading the wrong one. Mercury has degrees on the sun side of 426 degrees Celsius, and on the alternate side, minus 173 degrees. Talk about wind chill. Mercury is a cratered planet. Let's see. Only 2 spacecraft have ever visited Mercury. In 74 and 75, Mariner 10 flew by Mercury 3 times. And in 2004, the Messenger probe was launched from Cape Canaveral. It's the first spacecraft to visit since the 70s. Mercury is named after the Roman messenger god. It has an atmosphere, sort of. It's just 38% of the gravity of the Earth. This is too little to hold on to what atmosphere it has, which is blown away by solar winds, however, which create the comet tail. However, while gases escape into space, they are constantly being replenished at the same time by the solar system winds. So, where to view Mercury from now to the 14th? You can look for it just shortly after sunset. And this is taken from the Earth sky. Now, what's more interesting, and another photo op, is going to be on the 14th. We're going to have a crescent moon right next to Mercury. So I'm looking forward to some pictures from that. Everybody still hearing me at home?
Yep, I
Yes.
hear you.
Okay, I can't see you, so I have to just take your word for it. And here's another chart, which I'm not going to go into again. I'll put this out. These are all what this chart will shows you is on each day the altitude in the sky. So it on the 6th tonight it's 10 degrees above the horizon, and on the 18th it's now to 6, and then the phase of Mercury. So as it's going on in the month, it's getting lower and it's becoming more of a crescent because it's getting closer to the sun. On the tomorrow, 2 days, it's going to be a dichotomy. That means it's going to be a half moon or half Mercury. Sorry, which should be interesting. Again, if Frank, I expect some pictures.
Yeah, you want to, you want to.
So this is an interesting. So what does this chart show? This chart is using Star Charter. It's a command line tool to produce a vector graphics chart of the night sky. Uh, it's free to use, free to download. The markers on there each day are drawn at midnight UTC. The path of the planet is taken from the DE 430 planetary ephemeris, computed by the Jet Propulsion Laboratory. And data extracted is used to also calculate asteroids, orbital planes, and some minor planets. So what you can see, where's the markers? This. So I don't know if you can see over here. If you're looking to find Mercury, you have fixed points in the sky, you have some stars, and you might be able to locate Mercury that way if you're having some trouble. So I thought this was an interesting tool. I was playing with it. I just picked from today on, but you can plug in any planet, you can plug in some other objects, and you can then, if you're looking to do some observing, you can actually plot in the sky where these objects will be over the course of whatever time frame you want to give it. So, question, why does Mercury, even at the greatest elongation from the sun, appear at different angles? I thought this was interesting. So sometimes during the year, they're more favorable for viewing Mercury than others. From here, it reaches a peak, it generally reaches a peak between 9 and 21 degrees above the horizon. This year, it's going to be 10 degrees, and today and tomorrow, the next couple of days. And then it's going to get lower and lower. So when Mercury is widely separated from the sun, it's separated along the line of the ecliptic, but at different times of the year, the ecliptic meets the horizon at different angles at sunset. This means that Mercury appears at different altitudes above the horizon at different times of the year. At sunset, the ecliptic makes its steepest angle to the horizon at the spring equinox in March in the northern hemisphere and in September in the southern hemisphere. Conversely, if the horizon is at its shallowest angle in the autumn equinox, because the seasons are opposite in the north and south, a good apparition of Mercury in one hemisphere will usually be a poorly placed one in the other. At sunrise, these dates are also inverted when it becomes a morning object, so that morning apparitions of Mercury, the ecliptic makes its steepest angle to the horizon at autumn equinox and its shallowest at the spring equinox. So, Mercury's orbit also has a lot to do with how we see it in the sky. Secondary effect usually is the planet having significantly non-circular orbit, which varies its distance by the sun by 52% between its closest approach, the perihelion, labeled P, on the left there, and the diagram to the right, and the greatest difference, aphelion, labeled A. This means that Mercury's separation from the sun at greatest elongation varies depending on where it lies relative to the aphelion or perihelion points in orbit in mid-September through March, Earth is well placed to view the long axis of Mercury's orbit on edge. So if Mercury appears in the evening sky, say in mid-September, or in the morning sky, say in mid-March, then it appears more widely separated from the sun than usual. Specifically, at each apparition, Mercury reaches a separation from the sun of between 18 and 28 degrees. During the November-December apparition, this will reach a maximum separation of 21 degrees to the sun's east at greatest elongation. So it's 21 degrees from us, but because of our angle, when we get sunset, we only see it at 10 degrees. In the southern hemisphere, the optimum time for apparition for Mercury, the two effects described above are similar magnitude, though the inclination of the ecliptic to the horizon is more significant. They conspire to make Mercury much easier to observe from the southern hemisphere than from the north. In the southern hemisphere, apparitions of Mercury occur when the ecliptic plane is favorably inclined to the horizon, also coincidence with apparitions where Mercury is close to the aphelion. So in the northern hemisphere, unfortunately, the opposite is true. When the ecliptic plane is favorably inclined, Mercury is close to perihelion. So here, just a summary of some of the things that I talked about. It's a couple of 3 different slides. So you can see, again, this is from inthesky.org, where I got most of the information from. And there, so again, I'll be putting that out. And that is my talk.